Okay, this is homework 1.10. I'll be going over problems 4, 5, 31b, 33, and 41. So 4 is giving you a reaction and a condition. The condition is that if your pressure decreases and your pressure increases, the volume will change in correspondence to that. So what does that mean? If you have a low pressure, that means that your molecules aren't colliding as much. So what can you do to fix that? You can make the box they're in smaller so that there's less room for them to not hit each other. So they'll hit each other more, there'll be more collisions, meaning that there will be a higher pressure. And the reverse is also true. If your pressure is too high, you can just give them a larger volume so that they collide less. There's more open space for them to move around in without hitting each other. So that's our context for the questions. So now let's get into the questions themselves. So for A, what happens to the volume of the container as a result of the reaction? So at constant pressure and temperature, the container volume is directly proportional to the number of particles present. So when we look at our actual reaction, we have 3 moles of reactant bonding together to form 2 moles of product. So that means that at the end of this reaction, you're going to end up with one less molecule because they collided together, they bonded together to form a bigger molecule. So at the end of all of this reaction, like all of these reactions and everything has reacted, you're going to end up with 2/3 of what you originally had because a third of them bonded together to form carbon dioxide. So that means you're going to have a lower pressure. And what do you do with a lower pressure? You decrease the volume so that there's less room for them to move in. So that makes the pressure higher again. So what would happen? The volume would decrease. All right, for B, if the piston is not allowed to move, what happens to the pressure as a result of the reaction? So at constant volume and temperature, pressure is proportional to the number of particles. So since the number of molecules decreases as the reaction proceeds, the pressure also decreases. So when we're all done, the final pressure would be 2/3 of the initial pressure because the piston never moved, so you just have lower pressure. So yeah, that's the answer, lower pressure. So 5. Suppose you have a fixed amount of an ideal gas at a constant volume. So constant volume means that you have them all in the box and there's like 5 of them, for example. Now, if the pressure of the gas is doubled while the volume is held constant, what happens to its temperature? So that means these things are colliding a lot more without a volume change. So what happens here? Like, what would have to happen for this to happen where, like, your volume is decreasing, like, as I said before, if your volume is decreasing, that means that your pressure is increasing. But that's not happening. So what happens to the temperature? Well, the temperature adds more energy to the molecules. So the molecules are going to move around more. Consequently, they're going to collide more. So yeah, that's the answer. The temperature has to double. The temperature has to increase. So yeah, on to the next problem. Okay, I skipped 31 because it's a little obvious. So 33. Suppose you're given 2 1-liter flasks and told that one contains a gas of molar mass 30, the other a gas of molar mass 60, both at the same temperature. The pressure in flask A is x atm, and the mass of the gas in flask is 1.2 grams. The mass is the same for both flasks. All right, then the pressure in flask B is 0.5 x atm, which contains the gas of molar mass 60 and which contains the gas of molar mass 30. So as you can tell, the volumes are the same. The pressures are different, where pressure is double in flask A and the pressure is half in flask B. But the mass is the same, and so is the temperature. So what's changing the pressure is definitely the mass. So since one of them has a lower molar mass, that means the one with the lower molar mass is going to have more moles of gas in it. And more moles of gas means that there's higher pressure because there's more molecules running around. So the one with molar mass 30 should have a higher pressure because, again, there's more molecules in the same space, so the pressure is going to be higher. And then for molar mass 60, there's going to be less moles because 1.2 divided by 60 is a smaller value than 1.2 divided by 30. So that means that flask A is the one with molar mass 30 and flask B is the one with molar mass 60. Okay, and as for 41, sorry, I actually put the picture of 40, but it's 41, sorry. This is just plugging in P equals nRT. A scuba diver's tank contains 0.29 kilograms of oxygen compressed into a volume of 2.3 liters. Calculate the gas pressure inside the tank at 9 degrees Celsius. So first thing you need to do is just convert kilograms of oxygen to moles of oxygen. I got 9.1 moles, and then you just plug in your values for PV equals nRT. So 2.3 liters for volume, 9.1 moles for N, 0.082206 for T, which is the constant, and 282 degrees Kelvin. And from that, I got 91 atmospheres. And then for B, again, it's PV equals nRT. What volume would this oxygen occupy at 26 degrees Celsius and 0.95 atmospheres? So you plug in 0.95 for pressure. V is your unknown variable, and then equals 9.1 moles of oxygen, 0.08206 for R, and 299 degrees Kelvin. And from that, you get 2.3 times 10 to the second liters, or like 230 liters. And that's your answer, and that's all. Enjoy your night.